Alright, so today we're going to start our unit on transformations and basically what the transformations of polygons look like. We're going to focus on the type of polygons called quadrilaterals. So our goal today is to identify some of the properties of quadrilaterals so that we can most accurately classify these shapes. Also note that to be considered a quadrilateral, a shape has to have two things which are true. Okay, it has to be a close-sided figure that has four sides, and all of the interior angles have to add up to 360 degrees. All the shapes that we're going to talk about today are going to be quadrilaterals. They all have four sides and they all have interior angles that add to 360 degrees. In addition, if certain criteria are met, then quadrilaterals can be subclassified into other groups. Quadrilaterals can be classified as parallelograms, or trapezoids, or kites. And then if a quadrilateral, if we have a four-sided figure that doesn't fit into either of these three categories, then we just label it as a quadrilateral, and that's as specific a classification as we can get. So let's look at those subgroups, and let's start by looking at parallelograms. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. Okay, so I have to have this side parallel to its opposite side, so QR is parallel to PS. Okay, so in this case we use, remember our little beak marks that we talked about way back at the very first of the year. We use these little beak marks to tell me that these lines are parallel. So QR is parallel to PS, and segment PQ is parallel to segment RS. Okay, so I have two pairs of parallel sides. And also this symbol, this is to be read parallelogram PQRS. So if you see this symbol, it means that it's given that this is a parallelogram, and all of the properties of parallelograms apply to whatever this figure is. Okay? So in addition to the major criteria that we have to have two pairs of parallel sides, parallelograms also have four additional and more specific properties. So opposite sides here, not only are opposite sides parallel, but opposite sides are congruent. So my side opposite QR is PS, so QR is congruent to PS. And then side PQ here, its opposite side is not only parallel, but congruent. So opposite sides are congruent. Okay? Also, opposite angles are congruent. So here I have angle P. In a parallelogram, the angle opposite it, or R here, these are going to have the same measure. They are congruent angles. So for angle Q, its opposite angle S is congruent. Okay? So if opposite angles are congruent, then consecutive angles, so P and Q, they're consecutive because they're together on the same side and there's nothing in between them. Okay, so they're consecutive angles and they are supplementary. So let's highlight Q and P. Okay, so if they're supplementary, angle P plus angle Q, supplementary angles add to 180 degrees. Likewise, we have these pairs of consecutive angles, so they too are supplementary. So angle S plus angle R adds to be 180 degrees. Okay? So opposite angles are congruent, consecutive angles are supplementary. And one last thing to qualify something as a parallelogram is that the diagonal drawn between opposite angles, so between P and R, this is my diagonal PR, and I have a diagonal between these opposite angles, Q and S. Okay? These diagonals bisect each other. Remember that the word bisect doesn't mean they just intersect. It means that this point where they intersect divides QS into two congruent pieces, and it divides PR into two congruent pieces. Okay? So where they intersect bisects them, so QS is divided into two congruent halves, and PR is divided into two congruent halves. Okay? So those are all of our properties of parallelograms. Now let's take a look at a special parallelogram, which is the rectangle. For an object to be a rectangle, all 5 of those previous properties of parallelograms have to be true. I have to have opposite sides that are parallel. I have to have opposite sides that are congruent. I have to have opposite angles congruent. Consecutive angles are supplementary, and my diagonals bisect each other. In addition to all those properties of parallelograms, rectangles also have all of their angles as right angles. So not only are R and C congruent to each other, but R and E are congruent to each other. So all of my angles are the same and they're all 90 degrees. Additionally, the diagonals now are congruent. So I have the diagonal RC, so segment RC is congruent to segment ET. Okay, so each one of these segments is the same length. We also have another type of a quadrilateral, and this is not a parallelogram, okay? Not a parallelogram. But it is a quadrilateral because it's a 4-sided figure and all of my angles will add up to be 360 degrees. For an object to be called a kite, we have to have 2 disjoint pairs of consecutive sides which are congruent by definition. What this means, disjoint pairs of consecutive sides, means that if I use TI, I can't use TI in another pair. So when I pair TI or IT and ET, those are congruent. So that means I can't say IT and IK. I can't use this side again. So basically it's just telling me that these 2 sides are congruent and then these 2 sides are congruent. Okay? I have a pair of joined sides that are congruent. I also have 2 diagonals, and my diagonals are perpendicular. Remember that perpendicular means that these 2 diagonals will meet at 4 right angles. Additionally, one diagonal is the perpendicular bisector of the other. They both don't bisect each other, but one, TK here, is bisecting IE. So here, I to this point and this point to E are the same length. So this segment, IE, is divided in half at this point of intersection. And then we have a pair of opposite angles which are congruent. And in this case, angle TIK, this angle, is congruent to TEK. So this angle is congruent to this angle. Okay? Now we're going to look at another special case of parallelogram. We're going to talk about a rhombus. So the rhombus is not just a quadrilateral, but it's also a parallelogram, and it is also a kite. Okay? So for an object to be considered a rhombus, it has to have all the properties of a parallelogram, and it has to have all the properties of a kite. Okay? So you can go back and look at those properties if you need to. Additionally, a rhombus has every side is congruent. So MO is the same length as OH, is the same length as HR, is the same length as RM. Okay, so all the sides are the same. Every angle is bisected by a diagonal. So that means angle M here, MH divides M into two congruent angles. So each one of these angles is divided perfectly in half by the bisector. The diagonals are perpendicular bisectors of each other. So in a rhombus, my diagonals will intersect at 4 right angles, and it divides each one of the diagonals into two congruent halves. So this piece is the same length as this is the same as this. And lastly, these diagonals will divide this rhombus into 4 right triangles. So here's my right triangle, okay, with my right angle, and each one of these right triangles is exactly the same. Okay? So those are the properties of being a rhombus. Another special case is the square. A quadrilateral is a square if it is a parallelogram, a rectangle, and a rhombus. Okay? So I have to have all the properties of rectangles, and by default I have to have all the properties of parallelograms. I have to have all the properties of a rhombus, so that's where my 4 congruent sides come into play. But finally, the diagonals form 4 isosceles right triangles. So that means that this is congruent to this, is congruent to this, is congruent to this. These are right angles. And this angle has to be 45 degrees. This angle has to be 45 degrees. This angle is 90. So all of my outside angles will add to 90 degrees, and they are all bisected into 45-degree angles by the diagonals. Okay? You overwhelmed it? Well, we have one more type of shape to talk about, which is not a parallelogram. So if a shape is not a parallelogram and it's not a kite, it might be a trapezoid. And to be a trapezoid, a quadrilateral needs to have one pair, and only one pair, of parallel sides, and we usually call these sides bases. Okay? So we can have here, these two sides are parallel. So these are my bases. And then I just have 2 other sides that are not parallel. So this is a trapezoid. And with trapezoids, we can have a special case. We can have an isosceles trapezoid, where it has 2 sides which are the same length. So here are my parallel bases. Okay? And then these 2 legs, the non-parallel sides are called legs, are congruent to each other. Remember, an isosceles triangle has 2 congruent legs. Isosceles trapezoid has 2 congruent legs. The consecutive angles of the bases, so this means P and A, let's highlight P and A, are consecutive angles. And these consecutive angles are congruent. So P is equal to A. And we also have the consecutive angles of the top base. We have T and R, and they are congruent. So in this case, angle T is congruent to angle R, okay? And I don't want to write in yellow down here. Angle P is congruent to angle A. This being true, any angle down here is going to be supplementary to any angle up here. So P and T add to 180 degrees, or P and R will add to 180 degrees. Likewise, A and T can add to 180 degrees, or A and R can add to 180 degrees. So let's do a quick graphic recap of all that information that we just learned about quadrilaterals. Quadrilaterals can be grouped into 4 major groups. We have quadrilaterals that don't fit into any other category, so we just leave them as quadrilaterals. We just have a 4-sided figure. Then we have trapezoids, which have 1 pair of parallel bases. We've got parallelograms that have 2 pairs of parallel sides. And then we have kites, which have 2 pairs of consecutive congruent sides. Then, when quadrilaterals start to share properties, the categories condense into new categories. So if we have trapezoids, but we have a trapezoid that has two congruent legs, it's an isosceles trapezoid. When we have a parallelogram, but it has four 90-degree angles, it's a rectangle. When we have something that is both a parallelogram and a kite, it's a rhombus. And when we have a shape that is both a rhombus and a rectangle, it's a square. You got it? Alright, well in part 2 we're going to look at some examples and do a couple of problems using the properties of quadrilaterals, including a pretty lengthy proof about proving the perimeter of a parallelogram. So stay tuned to part 2 of our video.